Hello. Hello, Aslam class. Welcome to your maths lesson today, which is the 21st of January 2021. Write our date in the number format 21. That's 21 days. First month of the year, which is January, the year 2021. Okay, so as always, we're going to start our lesson off with some arithmetic. So I'm just going to share my screen with you. Here we are. And here are your arithmetic questions for today. Now, I know some of you have been really good with your maths this week and even spotting mistakes that I have been putting in. So well done. Right, here are your questions. Pause the video. Give yourself no longer than about 10 minutes to answer these questions. There are 10 questions. Each question you shouldn't really spend more than a minute on each question. Some questions may take you longer than others. Some questions may only take a couple of seconds to answer. So just do the best that you can, please, with these questions. Pause the video. Okay, good, it's recording again. So I'm going to stop sharing my screen so you can just see the answers for the questions. So for question 1, you should have 24. For question 2, you should have 5,997. For question 3, you should read C, D, L, I, X. Just to show you, whenever you have a 4 or a 9, because the Romans, they would say, like, if you wanted to show a 4, it would be 1 before 5. If you wanted to show 9, it was 1 before 10. That applies for 90s, for the 10s. So 40 would be 10 before 50, which is an L. 90 would be 10 before 100, which is a C. So for 400, we need to do 100 before 500. 500 is represented by a D, so 100 before that is 400. So 400 is represented as CD. 100 before 500 is 400. 50 is L, and then 1 before 10 is 9, which gives us the 9 there, okay? So 459. Question 4, the answer is 89. The sequence was going back in threes. Question 5 is 18. Question 6 is 16. Question 7 is 10.5 or 10 and a half. We haven't really looked at decimals yet, but well done if you got that one correct. For question 8, the answer is 4,246. Question 9, 150 millimeters is actually 15 centimeters. You just divide it by 10 because there are 10 millimeters to every centimeter. I've got the hiccups. And question 10, the answer was 7. So there we are. Well done for getting to doing them questions. I'm now going to go back to my screen share and go on to move into what we're doing today. So today is all about, can you find the area of a shape by counting squares? Now, yesterday we were looking at area and we were looking about how it is the space inside a 2D shape. And what we did yesterday, you should have been able to see when you start putting shapes together inside an area, the easiest way to divide your shape up is into squares. Okay. But before we start that, here is a quick challenge for you. I want you to tell me which one is different. Okay, so you can pause the video here, read through these. Okay, Amy colouring the squares in her maths book, Jermaine covering his desk with playing cards, a decorator painting the ceiling, Dylan measuring the width of the classroom, Mr. Wilson deciding how much carpet she needs to buy, and Claire seeing how many labels she can stick on the front of her book. Which one is different? Which one's the other now? Pause the video. Okay, welcome back. Hopefully you've had a bit of time to think about that. Now, some of you may have loads of different answers here, but we are focusing on area. So let's try to relate these to area. Amy colouring the squares in her maths book. Yeah, that's area, isn't it? Yeah, we're looking at using squares today. Her maths book is a page and she's colouring in all the squares, finding out how many squares there are on a page in the book. Yeah, so that could be area. B, Jermaine covering his desk with playing cards. Yesterday, I did it with Pokemon cards. Some of you may have given it a go yesterday as well. So playing with playing cards is another way of finding out the area. A decorator painting a ceiling. So I'm painting a ceiling, okay? Is that area? Yeah, it is, because the ceiling is you're only doing the ceiling, okay? It's one surface, one flat surface, and you're painting the whole of that surface. So you're painting the area of the ceiling, aren't you? Dylan measuring the width of the classroom. So he's getting a tape measure and he's just measuring the width. Is that going to help his area? No. He also needs to find out the length of the room as well to find out the area. So just finding out the width of the classroom isn't going to help. So that one, by process of elimination, is the odd one out. The other two, carpet, yes, you're going to need to figuring out how much carpet you're going to lay down on the floor. You're covering the floor space on the floor. So that is area. And Claire's seeing how many labels she can stick on the front of her book is also area as well. So well done if you got that one correct. Okay, so here you can see on the screen, we have a rectangle, okay? And what we're going to do, we're going to work through this together and we're going to complete the missing information to find the area of the shape. So listen carefully. Each of these small shapes, I need to get my pen out for this one. Let's get a red pen. So each of these small squares has a length of how many centimeters? Have a look up here. This is showing us that this square is how many centimeters in length? Good, it is 1. And has a width of, and the width again here is 1 centimeter, very good. We say that there are, how many squares. So how many, we say that there are 1 squares and they each have an area of 1 square centimeter. So there's 1 square and they have an area of 1 square centimeter, or it can look like that, 1 cm, and the little 2 here represents what square means. Sorry, I was just reading that. So each one of these squares has an area of 1 centimeter squared. Now we know that, we then count up how many squares that fit inside our rectangle. So how many, like the other day I was saying, how many Pokemon cards fit into that shape? How many of these 1 centimeter squares are going to fit into this shape? And this is how we work out the area accurately. Okay, so we're not using Pokemon cards or playing cards or marbles or whatever anymore. We are focusing on the squares. Okay, and you can see here that we have 1, 2, 3, 4, 5, 6, 7 squares going across the top. 1, 2, 3, 4, 5, 6, 7. We're going to have another 7 going across here, aren't we? So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So 28 small squares fit inside our rectangle. So we can now say that because each square is 1 centimeter, has an area of 1 centimeter, there are 28 of them. So now we can say that our area of this shape is 28 centimeters squared, or 28 cm, and then the little 2. And the little 2 there tells us that we are squaring it, that it's squared. Okay. So hopefully that makes sense. When we look at area now, we are looking at the number of squares that are inside our shape. Depending on how big each square is how big is the measurement we're measuring. If this picture said that each square represents a meter, it would be a meter squared. But let's just keep it safe for now and look at centimeters. Let's have a look at our next one here. So count the squares to find the shapes in the area. I'm going to go through the first one with you, and then you give the other two a try yourself. So here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this shape, there are 9 squares. And if each shape was and if each square represented 1 centimeter, it would be 9 centimeters squared. So give it a go, pause the video and do B and C, please. Okay, welcome back. Hopefully you found that okay. So for B, we count the squares. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this area has, this shape has an area of 10 squares. And here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this shape has an area of 11 squares. So well done if you got them 2 questions correct. And now we have to answer the next one. Which one has the greatest area? Greatest means high, it means largest. So which one has the largest area? And of course it's this one here, isn't it? Because it has 11 squares, which is greater than 10 and 9. So the shape that has the highest area is shape C. Okay, so I'm going to go through another question with you. Class 4T and Class 4M are comparing the area of their classrooms. Whose classroom has the larger area? And explain your answer. It says to a friend, to a family member, or you can write it down and put it up onto tapestry. So here, you may want to use your whiteboards. On the back, there's squared paper. You may want to use this when you're doing your work. So let's have a look here. We've got now our class, look, we're measuring in meter squares now. So each one of these little squares has a length of 1 meter, a width of 1 meter, and an area of 1 meter squared. We're now going to count how many squares fit into each of our classrooms, okay? So this one we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So this has an area of 28. The unit we're measuring in is in meters for this question. And then we put a little 2 to show that it is squared. So 28 meters squared. Now let's go over to class 4M and see how many meter squares fit into this shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So in class 4M, their floor space, the space that they have within the room, is 30 meters squared. So when we come to looking at our question now, we need to answer this part. Whose classroom has the larger area? Class 4M has the larger area. And if you were to explain that to someone, you would say, because each square represents 1 meter squared. There are 28 of these squares in class 4T, giving them a total of 28 meters squared. But in class 4M, they have 30 of these squares, therefore it's 30 meters squared. So I want you guys to give this one a quick little go on your own. So there are 2 shapes made up of squares of the same size. Here are the 2 shapes. Jack says these 2 shapes have the same area. Rosie says the first shape is bigger as it takes up more space, and it looks like it does. But who is correct, and explain how you know. So try and answer this question. Pause the video. Okay, welcome back. Hopefully you've been able to answer this question. In order to answer this question, we need to work out which shape is larger, or are they the same? Now, Jack's shape here, it does actually look bigger than this shape, doesn't it? Okay, but when we count the squares in this shape, we'll see how much this shape actually takes up in terms of area. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then over here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So who is right? Is it Jack or is it Rosie? Well, Jack is correct. They do have the same area because this one has 9 squares and this one has 9 squares. Rosie thinks this one is bigger because it does look bigger, doesn't it? It does look bigger. It's spread out. However, it is taking up the same amount of space. It's taking up the same area as this shape here. So they both have 9. So Jack is correct, and you know how you've explained it because you've counted the squares and you found out that there is 9 in each square. Okay, a quick little quiz for you guys. True or false? Ellie makes a shape by colouring in 15 centimetre squares. Her shape has an area of 15 centimetres squared. Is it true or false? It's true because each square is represented, she's filled in 15 centimetre squares. Okay, so 15 squares, each one's a centimetre, so that's true. 70 centimetres means the same as 70 centimetres squared. If you said true, you're wrong. It's false. 70 centimetres is just a length. Okay, it just tells us from here to here. 70 centimetres squared is telling us the space inside a shape. Okay, so be careful with that one. C, a carpet tile has an area of 1 squared metre. Lottie puts 9 of these carpet tiles together to make a square. It has an area of 9 squared centimetres. Is this true or false? If you said true, you are right. Yes, you are right. Excellent. Yeah, because each square is 1 metre squared. She's got 9 of them, so that's 9 metres squared. Oh no. You're not right. I spotted the mistake before you guys. No, you are. It is false. In fact, the tiles are squared meters, so it should have an area of 9 squared meters, not centimeters. It almost tricked me out there, that one, but no. So no, that one's false. C is false. And D, the blue rectangle has a smaller area. Now, if you have a look at these squares here, D has 3, 6, the blue one has 3, 6, 9, 12, 15, 18 squares. And then our other one has 4, 8, 12, 16, 20. So the blue rectangle has a smaller area, and the answer is true. So it should be true, false, false, true. Okay, your independent work for today, okay? You may need to use the back of your whiteboard and use the grids on there to help you with today's lesson. In fact, it's going to be imperative that you use that. So, number 1, here is a kitchen tile. What area of the tiles are blue? What area of the tile is white? And then what is the total area of that kitchen tile? Question 2, find the area of each rectangle. And then for challenge number 3, Niger and Ava are making shapes. They use 6 squares, and there's Niger's shape and there's Ava's shape. The area of Niger's shape is equal to the area of Ava's shape. Is this true or is this false? How do you know? So that's your 3rd question. Okay, you may need to pause the video, whatever question you're on. I'm now going to go through the answers after you've done the work. So pause the video and let's go and do the work. Okay, welcome back, Aslam, to the answers. So for question 1, it says what area of the tile is blue? So this tile here, how many squares are actually blue? We got 1, 2, 3, 4. So it's 4 squares. You can use cubes to help you with this, or other objects, Lego bricks at home. If you've got that, you could put them together and see. What area of the tile is white? Let's count. 1, 2, 3, 4, 5, 6. And then the total area of the square, 6 plus 4 is 10. So well done if you got them correct. Now let's go over to these questions here. Find the area of each rectangle, okay? So we've got 1, 2, 3, 4, 5, 6, 7. So shape A is 7. Shape B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So well done if you got 10. And shape C is 1, 2, 3, 4, 5, 6. We then got another 6, 7, 8, 9, 10, 11, 12, and then another 6 here, okay, which gives us 18, and then I add another 6 here, which gives us 24 squares. For some of you, you may be able to see a pattern of how to work out area in shapes like squares and rectangles. Now, this question here, this one is a little bit tricky. Okay, so the area of Naya's shape is equal to the area of Ava's shape. Is it true or false? Well, let's have a look at the shapes. Ava's shape looks a lot bigger, doesn't it? Okay, that looks massive. Compared to Naya's shape, it's smaller. However, we don't know what the measurements are. We don't know whether each of these squares represents a centimeter or a meter. This one could be a meter, this one could be a centimeter. However, in terms of area, this one does look bigger, so we could say that this is actually a bigger shape because it's bigger than this one. So this one will have a larger area because it is bigger, and naturally things that do look bigger will probably have a higher area. However, you know, if you can explain that and justify it, that's fine. However, we do not know what these measurements are in. So Naya's shape is 6 squares, and Ava's shape is 6 squares. If we were talking about the shape in squares, they both have the same area because they both have 6 squares in them. We don't know what the measurements are, so we can't be 100% sure whether these shapes have different dimensions. This one looks a bit bigger, but that could be zoomed in, okay? This one could have been zoomed out. So in terms of just, if we were just looking at how many squares are being used, the area is equal to, they share the same area because there are 6 squares each. If, and it is it if each of these squares was 1 centimeter and each of these squares had an area of like 1 meter, this would have a larger area, but it doesn't stipulate that. So for this question, the area of Naya's shape is equal to the area of Ava's shape. Is it true? It is true, because we know it's true because they've used the same amount of squares. Okay. If you put false and you said that this shape is bigger, you could accept that as well because, you know, things that are bigger normally do have a bigger area than other things. Like, for example, this rectangle here is bigger than my rectangle on my screen. So, so this shape, you could argue that that is bigger. As long as you can justify your answer, that's absolutely fine. So if you put an answer that says the shape is equal, because they've used 6 squares each, that's fine. If you've put Ava's shape is larger, therefore it should have a larger area, then that is also okay. So as long as you can explain your answer, I don't mind. Right, that's today's lesson finished. I hope you've enjoyed that. It is area, so it is a little bit different, maybe not so much taxing as division and multiplication. Good luck. Any questions, please don't hesitate to ask. See you in the next video.